Hi guys, welcome back to the channel. My name is Jag, and in today's class we're going to cover Chemistry 11, and this is a very important topic. We're going to cover the topic of moles today. And again, moles is basically just seen as like a quantity. It's kind of like a standardized unit to describe the amount of something, okay, whether it's a substance or matter, and we're just basically using the word moles, okay. So what we're going to start off with is basically the formula for moles, okay? I'm going to draw out this triangle, okay? So everyone can see how the moles, the mass, and the molar mass are related to each other. Okay, so I'm going to draw the triangle right here. All right, so at the top of the triangle is going to be the mass, okay? On one of the sides, I'm going to put n, okay? This is a lowercase n. And this represents the moles, okay? So, and let's just write it on the side here. So this is the mass. Okay, the unit for mass should always be in grams, okay? So again, if it's in kilograms, I'm just going to multiply by 1,000, and I'm going to convert the kilograms into grams before I use the formula. Okay, and n is the number of moles, okay? In this last box, I'm going to put capital M and lowercase m, okay? This represents the molar mass. So I'm just going to write it here, molar mass, okay? And remember the units for molar mass is grams per mole, okay? So I'm going to put it in brackets here. And again, every time you calculate the molar mass of a compound, make sure you are putting the units, okay? Again, the units are grams per mole, all right? The molar mass of a compound is actually calculated by using the mass that you see in the periodic table. Okay, if you're not sure how to do this, you can check out one of my previous videos, which was just on calculating the molar mass of various compounds. All right, so let's write out the formulas, okay, before we try an example. So say I'm looking for the mass of a compound, okay? All I'm going to do is multiply the other two variables, okay? So the mass is equal to the moles times the molar mass, all right? And let's actually put a box around it. So that's the formula for mass. We actually use this formula very often, okay? So either you are memorizing the formula or you are memorizing this triangle, so I don't need to keep going through all these different formulas in my head, okay? Now say I'm looking for the number of moles. Even calculating the number of moles, this formula is also used quite often, okay? As you can see how the mass is at the top of the triangle, I have to make sure I am dividing. So I'm going to do the mass divided by the molar mass. Okay, does everyone see that? All right, I'm going to write down this last formula. However, we're not really using this formula too often for the molar mass. Okay, but if I were to use the formula for molar mass, again, the mass is at the top of the triangle, so I'm going to do the mass divided by the moles. Now the reason we don't really use this formula for molar mass is because I can find the molar mass of the compound by just using my periodic table over here. And I'm just using the mass of each of the elements. Again, make sure you are counting the number of atoms when you calculate the total molar mass of the compound, and don't forget to put the units, okay? It's grams per mole. And I know I keep emphasizing this, but teachers are taking off marks all the time, okay? And that's something that we can avoid, okay? So we should be avoiding these small mistakes. All right, so if there are no questions, we're gonna go into the textbook and try this example, okay? So again, I'm going to read the example out loud, okay? But I'm still going to write down what the question gives us. That way we know which formula we need to use here. All right? Okay, so a flask contains, I'm going to put example. A flask contains 0.750 moles. So I have the number of moles. Okay, of carbon dioxide gas. Okay, so I'm going to put CO2. All right, and what mass of carbon dioxide gas is found in this sample? Okay, so I can see that I'm actually looking for the mass of the compound, okay, which is carbon dioxide. Again, I don't have to give you the actual formula, I should know how to come up with the formula, whether it's a molecular compound in this case, or even if it's an ionic compound. So that's actually the only way your teacher can try and trick you. Okay, so we have to make sure we keep practicing how to write out the chemical formulas. All right? In the first step here, okay, I'm going to find the molar mass. So I'm going to put capital M, lowercase m of carbon dioxide. All right, so you can look in your periodic table here, okay? The mass for carbon is 12. And the mass of one oxygen atom is 16, okay? So we're going to do 16 times 2, okay? Because I can see that there are 2 oxygen atoms here, okay? We're going to add them together, all right? And we're getting 44 grams per mole. Okay, now carbon and oxygen have basically, there are no decimals if you look in the periodic table here. Okay, they're basically whole numbers. However, if you do see a decimal, it is alright if you feel like rounding all of these masses. You can round it to the nearest whole number, okay? And teachers will not take off a mark for that because it's not going to make a difference again in the overall answer, alright? So we have our molar mass for CO2, okay? And I also have the moles. So again, I'm looking for the mass. Always write out the formula before you plug in the values, okay? So if I'm looking for the mass, it's moles times the molar mass, okay? I'm going to write it going down here. Okay, so the moles is given in the question. It's 0.750 and times the molar mass that are found in step 1, which was 44. Okay? So that's the molar mass for carbon dioxide. Okay, I'm going to take these two numbers, so 0.750, and I'm going to multiply it by 44. Okay, and we are getting 33 grams. Okay, because this is the mass, remember the mass is in grams. I can't put kilograms. It's not grams per mole. Okay, the grams per mole is only the units for the molar mass. Okay? So I'm going to write a therefore statement, and you should always make sure you do that, okay, just in case. As we move on in chemistry, there will be a lot of different calculations you have to do with many different steps. In this case, there are only 2 steps here, okay? However, teachers will not go around looking for your answer. The final answer should be in a final statement. That way they know that that's your final answer, okay? So I'm going to put, therefore, the mass of carbon dioxide, okay, in the sample, okay, is 33 grams, okay? And again, you notice in the final statement, I'm not actually writing out the chemical formulas, okay? I'm not writing out just G for grams. I have to write everything in words, okay? That's what a concluding sentence is. Okay, are there any questions? All right, I think that looks good, okay? So with that, let's try one more example here, okay? We're gonna take it from the textbook. And this time we're gonna actually solve for one of the different variables. Okay, and that way nobody should have any questions, okay? When you're doing this unit, there can be several variations of questions. The teacher, again, is going to try to trick you maybe on the unit test or the final exam, and we have to make sure we are prepared for that. Okay, so again, I'm going to read out the question, okay, and I'm going to write down what is given in the question before we apply the formula, okay? So it says how many moles of acetic acid, so I can see that I'm looking for the number of moles, okay? And the formula for acetic acid is given, so I'm going to just write it here. It's CH3COOH, okay? Now again, I don't need to actually memorize all of these different acids. It's really up to your teacher, okay? Some teachers do want you memorizing specific acids that are very commonly used in the laboratory, okay? If you don't need to, the question will usually give you the formula, all right? And it says how many moles of acetic acid are in a 23.6 gram sample, okay? So let's put the mass here. So we have 23.6 grams, okay? And as I can see, what I want to do first in my first step here is I want to find the molar mass of acetic acid. So I'm going to put mm of CH3COOH, okay? I'm going to just write it going across, okay? You should write it going down on your paper. All right, so if we're looking at carbon, okay, the mass of carbon is 12. And I'm going to times it by 2 because I see that there are 2 atoms of carbon here, okay? Then we're going to go to hydrogen, okay? So if you look in the periodic table, hydrogen is basically a decimal here. I'm just going to round it to 1, okay? So it's like 1 gram per mole times 4 because I have 3 hydrogens here, okay? I'm adding it to this last one. I have 4 hydrogen atoms altogether. Does everyone see that? Okay? Again, make sure you are counting the number of atoms here. Okay, and then we're going to add oxygen, which is 16, times 2 because I see there are 2 oxygens in the last part of the compound. Okay, so what we're going to do is just use your calculator. Okay, and we're going to add them all together. Okay, and we're getting 60 grams per mole. Again, make sure you are putting the units down here, okay? So for all of these questions, there are actually only 2 steps, okay? So let's go to step 2. And in the second step, what we're going to do is we're looking at what's given to us now, okay? And I'm looking for the number of moles. So if I'm looking for moles, again, if you're not sure about the formula, okay, take a look at the triangle that we drew out. So the moles equals the mass divided by the molar mass. Okay, I'm just going to plug in the numbers into this equation here. The mass was given in the question and it was 23.6 grams. Okay, divided by the molar mass that I calculated in step 1, which was 60. Okay, so we're just going to write it on the bottom here. Okay, so 23.6 divided by 60. And again, whenever you solve for the moles, you'll notice that it's a decimal and the numbers are always going to be really small. So we're going to round this to 0.3933 moles. Okay, as a general rule, I always round the moles to 4 decimal places. Again, you should check with your teacher, or some teachers are really specific and picky about the significant figures and digits. Always check with your teacher here. The reason I round it to 4 decimals is if I'm using the number of moles in another calculation, okay, I want to make sure that my answer is very accurate, okay? So try to round it to at least 3 to 4 decimal places, okay? So it says how many moles of acetic acid? So we'll put therefore 0.3933 moles, okay? I'm going to put of acetic acid, R, and we could just put R in the sample, okay? So again, try to make your final concluding sentence. It should be rather specific to exactly what the question is asking, okay? And again, I would just watch the rounding. Some teachers want you to round the moles at the end to maybe like 2 decimal places, okay? And again, that's really up to your teacher, okay? And I would always make sure I question that. I don't want marks taken off for something very simple like this, especially when I have the right answer, all right? So if there are no questions, that brings this video to an end. And again, we just covered Chemistry 11 on the very important topic of moles. Make sure you're doing a lot of practice questions from the textbook and try a variety of different questions. That way you can be using all of the different formulas that we covered. So thank you for watching this video. And again, make sure you're subscribing to the channel and click on the like button below because it makes a really big difference. And I'll see everyone in the next video. Thanks. Bye.